before we start, I'd like to share this term with you, broiler. Okay, so for poultry farm, we don't call the chicken, right? We call them broiler. It's because broiler means the chicken are raised for their meat. Okay, so in this section, we'll be referring to chicken as broiler. And coming back to the topic of poultry and fertilizer, what do they actually have in common? So first off, if you have been to a poultry farm, or if you have been to a fertilizer factory, you would know that both of them actually is perceived to be dirty and also smelly, right? I'll share with you what is the reason for that later, but let's just go through, how poultry farm looks like before, this current era. So old poultry farms look somewhat like this. There's a sketch where you have a roof, of course, and then you have large windows and also a door, right? So there's only going to be one door because you don't want the chicken to escape from the poultry farm. We've seen certain movies that, the chicken escape and all that, right? So for poultry farm, normally there'll be a certain mechanism or certain design that allows for the air to be ventilated naturally. Okay, so those are the olden days design. So this is some of the actual example in different regions of the world. So you can see from here, there's actually a large opening up at the end of the building. But in actual fact, there's actually a netted screen to prevent the chickens from escaping. So all these are actually meant to allow for better ventilation. And more closer to home in Malaysia, so this is what an olden days poultry farm or poultry shed would look like, where it is built with say papan and atap, and of course there's actually a certain level of natural ventilation and mechanical ventilation, but it was not really a systemized solution or systemized design. All right, move over to fertilizer factories. So these are photos that I have taken when we did some fertilizer factories inspection. So here you can see that the fertilizers are actually packed, and of course before it was packed, it was actually processed in the machine to become granule fertilizers, meaning by the BG one, right? So the understanding is that in fertilizer factory, you tend to have a certain irritating smell, and when you come out of it, you tend to feel your throat is drier, and of course your whole body is somewhat unease because of the environment that you have gone through. So typically it is perceived to be dirty and dusty as well. So especially if the factory itself is producing from a powdered version of fertilizer and mix them together to become granular fertilizer. And typically in this process, there will be a lot of dust, fertilizer dust or chemical dust flying around. So that's why this makes the fertilizer factories so corrosive. And of course, we'll talk about the prevention and what are the things that we have seen so far. So essentially, poultry farms and fertilizer factories requires slightly different designs. But again, in terms of prolonging the building, they both are facing the threat, the similar threat, I would say, where the threat itself actually originates from this cycle called nitrogen cycle. So this is a bit of background for those who are not very aware. So nitrogen is one of the most abundant gas, right, on the crust of our Earth. Of course, the nitrogen itself will be recirculated in this circle of life, where they'll be absorbed into soil, right, through certain bacteria or certain plant. And of course, it will be transformed into a type of component that is, consumed by animals. So when animals, let out their feces, it tend to recirculate back onto the soil and then back to the environment. So basically, what I'm saying is that nitrogen is actually the basic building block of flora and fauna, right? So us human, we also requires this nitrogen. It contains in our muscle and all that, right? So, but when nitrogen exists in nature, there's one of the form that is most abundant is called ammonia, right? Ammonia is something that is known to be first pungent. So if you have been to an ammonia environment, or so-called you have smelled ammonia, during chemistry class and whatnot, you know that it is actually a very pungent smell gas, and it could actually irritate your body and also eyes, right? So some of the characteristics of ammonia is that it's actually a hygroscopic substance, meaning this substance itself will actually absorb moisture if, let's say, there's any types of humid air around. So in the previous episodes, which I covered chlorine or salt, salt is also a type of hygroscopic substance, meaning they absorb moisture and then grow in size. The example I've shown here is actually silica gel, which most of the food packaging, dry food packaging, vacuum food packaging would have, right? So it works on the same principle. So ammonia, in nature, they are hygroscopic substance. But aside from that, they also have another characteristics where ammonia can easily dissolve into water, right, to form ammonium hydroxide or some kind of alkaline solution. It's because of these characteristics that ammonia can actually cause irritation and also harmful effect to eyes or skin. So that is why whenever you walk into a very an environment filled with ammonia, such as fertilizer factories, you tend to feel irritated because the gas that you are inhaling actually is dissolving. The gas is dissolving into the liquid, right, all over your body, including your eyes. So this is what makes it irritating, right? It dissolves readily. So these are the characteristics that I will mention later on to describe how is this ammonia corrosive and towards the building. Okay, and based on statistics or this study itself, it's shown that ammonia emission comes mostly from agricultural activities, and most part of these activities, ammonia comes from the what we call manure management. Manure means feces, also called poop, in common term. So in overall, we can say that 50% of the total ammonia emissions comes from manure emission. All right, comes from the feces, emitting out ammonia when it was breaking down or composting. So let's move into the first industry, poultry farm. So poultry farm means you're raising chickens or duck or any types of two-legged birds, okay, and raise it for their meat, for the food lah, basically. Okay, so poultry farm has a very simple cycle, right? So from breeder, where the chicken, for example, today we'll be just using chicken as an example. Okay, so chicken itself will breed will lay eggs. Typically, they would call breeder or layers, right? Like each layer, because they lay eggs, right? So they would lay eggs and then give the egg to the producer, and the egg itself can be hatched into chicks, right? Or they can be directly sold to end consumer, right? Tray of eggs and all that. And from chicks, there will be during the hatchery stage, they will actually send them to the broiler farm. So broiler farm is where they'll raise the chick into become a mature broiler, and then it will be sent for slaughtering. Okay, so this is a basic cycle, right? As simple as I can get it to be. Of course, the most so-called potentially corrosive activities are at the breeder stage or at the broiler stage. The reason why is because during this stage is where the chicken or so-called broiler is most active, okay, and is most mature. So that is where they will let out more feces or more manure in the facility. So let's look at how a breeder farm look like. Typically, a breeder farm would have nests, right? A tray of nests where chicken will sit there, enjoy their environment, eat the food, and lay eggs. Okay, so they will line up nicely. And this is another example where the nest boxes will be, laid out in such a way where chicken will go in and lay eggs. So the egg will roll down on the tray and, of course, sent to the hatchery facility where they'll incubate the egg in the industrial method and basically incubate the egg into become chicks when they hatch. So once they hatch, the chicken will be sent to broiler farm. So, and the chicken will be fed with balanced diet. They'll grow to become bigger exponentially within, say, 1 month and then 2 months. Right? It's actually quite scary to look at this diagram. So at this stage, we will know that modern farming, there will be bigger chickens, right? It's expected. And also at the same time, more manure, more feces coming out from them. Okay, so it is very crucial for us to actually be conscious about the manure and then how to manage it. So nowadays, the broiler farm will look somewhat like this, where there'll be a room where the chicks will be placed at, and then there'll be food, fed along the line. And of course, there'll be space for the chicks to grow into broilers. So when they grow fully, so this is where the broiler farm or the facility will be packed with broilers, right? So of course, we are looking at the broiler manure, so it is typically collected not to be disposed alone, but to be used as fertilizers, natural fertilizers. So when the manure is let out from the chicken, there will be certain biological substances that actually break it down to release ammonia. So this is actually, could be part of the composting process as well. So when it let out ammonia, so combined with the humid air within the broiler farm, because every chicken could let out a bit of moisture as well. So it contributes to the overall humidity of the broiler farm. So this is where the ammonia would readily dissolve and absorb moisture, and it will cause the environment to be very corrosive. All right. So based on one study, it shows that this is actually some figure here. So it shows that poultry poultry manure actually is one of the most corrosive one, all right, along with cattle and compared to benchmark of clean water. So you can see that poultry manure actually can corrode not just the mild steel and also galvanized steel, right? So it's partly due to the ammonia emission. So at the bottom, you can see a photo where the roof of a typical olden days so-called poultry farm, where back then there was no proper designing. So you can see there was actually rusting all over the roof, right? So all that manure can actually be very corrosive. That's all you have to understand, right? So that's why in this stage, it's very crucial to have a proper design, okay, for the poultry farms, right? Of course, if you ask a poultry farm, consultant or so-called supplier, they will know that, having a proper design is not just good for the building overall, it's also good for the chicken, because at the end of the day, they want to produce a chicken, that is stress-free, that is healthy and all that. So having this kind of design actually improve overall product, right, of the broiler. So of course, to start with, what we understand from the broiler, this kind of design is that the chicken needs to be living in a cooler environment. They cannot be stressed out by heat, right? If they're stressed out by heat, then the meat is not good. So at the intake itself, air intake, normally they will have a cooling pad wall, meaning it will be a filtered screen water fountain that will allow air to go through and then cool it down, just like your air conditioner. But of course, at the other end of it will be a ventilator. So one end of it will suck the air in, and the other one will suck the air from the broiler environment out, right? So proper ventilation actually could help with cooling and also refreshing the air for the broilers. But at the same time, also it could help with minimizing the ammonia that is contained within the broiler. That's why it's very crucial for these kind of farms to have an ample amount of ventilation. So here in this photo, you can see there are a lot of mechanical fans, right? The top level is quite a lot, and then the bottom only 2. So I'll talk about that later on, right? Why only 2 at the bottom and a row of it at the top. So that is the first ventilation. And the second one is on the flooring. So traditionally, the broilers are actually raised on the floor, right? On dirt floor, on cement floor, and so on, right? And sometimes they will actually lay sawdust to allow the manure that is laid out by the chicken to be composted with the sawdust and easy for collection as well, right? So in modern broiler farms, this is what you can expect. So they will not use the solid floor normally, but they will use what they call slated floor. So this slated floor itself is actually perforated and raised up from the ground. Okay, it looks somewhat like this in setup. So the reason for this is because first, it will allow for better ventilation, right? So you will not just have a floor that is solid, it's not having any air running through between the floors. So it will have air, venting through the top floor, like here. And there'll be air going under, to the bottom of the floor. So it could provide a better ventilation. And second, also, it could allow the manure produced by the broilers to fall through, right? So this allows for a cleaner platform, okay? So this is how it looks like at the bottom floor, basically a cement floor or concrete floor, and for the manure to be collected. And this is another one, better illuminated, right? So just now I mentioned about the ventilators, right? The fans. So the reason why there's only 2 fans at the bottom is because it's actually for this floor, right? Where there's nothing. And then on the top, it'll be a lot of fans because that is where the broilers are living in, okay? For 2 months before they check out. Okay, so once they check out, there's no more chicken, then the manure can be collected, right, on a periodic basis. Or in modern days, there are other mechanisms, right, like automatic conveyor belts, where, at a press of button or a simple setup, the so-called manure can be collected automatically at the end to be collectively taken out. So these actually could also minimize the exposure of the building to ammonia on a periodic basis. Perhaps this can be done once a month instead of once every batch of broiler, right? So once it's collected, normally there'll be a storage area where it's roofed and stored away from rain and sun. So this is where the manure will be placed at, right, away from the broiler farm. Okay, and there's a reason why it's actually roofed, which I'll talk about in the fertilizer area. All right, so of course, for poultry farm, other than ventilation, the flooring, right, and also the clearing of manure, of course, we'll have to talk about the roof, right? So from what we understand, the roof is very important to make sure that there is no leakages of rain and water through the roof to the area where the broilers are living. This is because it could potentially contaminate the broilers, by bacteria infection or whatnot. So that is why it's very important and crucial to have a fully sealed roof and away from external environment, right? So here we actually studied two types of roofing systems. Okay, so one that has nothing or has a different unsuitable type of membrane roof. All right. So another one is later I'll talk about it. So that the first one where here you can see one of the farm with different kind of membrane. I'll say the membrane was actually a felt-like membrane, a fabric-like membrane. So this roof itself, where we inspected, was already 4 years duration for service life, right? And after 4 years, you can see the purlins itself started rusting. Okay, here it started rusting, and the membrane itself did not only fail in protecting the roof, but it started actually absorbing moisture, right, from the humid air within. So this allows for the ammonia to condense at the humid membrane, right, or a so-called the moist membrane. And like I mentioned earlier, ammonia is a substance that readily dissolves into moisture. So what happened here in this roof was that the ammonia dissolved fully onto the membrane, and this created a very conducive environment for the roof to start reacting with this membrane because of the dissolved ammonia. And this accelerated the corrosion of the roof. So here you can see the bright dots where these are actually perforations, okay, meaning rusted until it perforates. Okay, so that is the first one where the roof can be without membrane or with membrane, right? With nothing underneath it means that there could be potentially condensation underneath the roof, and there'll be ammonia will be dissolving under the roof. Or it could be the membrane that is a wrong type of membrane where it could absorb moisture and then ammonia also dissolve into the moisture, right? So the second one that we studied, which is actually the same type of design, but different roof systems, and they were built in the same duration, 4 years. Okay, so the second type that we studied actually has a roof with a closed self-impermeable board, right? So based on principle, if let's say there is any membrane that is impermeable, right, or closed cell, meaning there will be no penetration of moisture or gas through this membrane. So based on the study, after 4 years, here you don't see any sign of purlin rusting. Okay, so this is because there was no moisture condensing underneath this membrane or board. And overall, you can see that there was no reaction or no condensation. But of course, from this environment, you can understand that there is certain bits of dust flying around because of the dirtiness of the farm itself. Okay, so one thing that we also noticed is that this board itself was actually chipped away by nature. It was a quite a thick board. And what we found out was that there was actually nests made by birds, because the insulation itself was actually very conducive for bird to live in, right? And of course, because of that, the chip away area, we saw some sign of corrosion where the fasteners, you can see here, the fasteners actually shown sign of corrosion and it spreads around the cladding as well. So this is where we noted and highlighted the importance of detailing. So when we went out to the external, we saw that, okay, the board was actually installed, not all the way, and then there was no covering, there was no flashing protecting this board. So what happened was it allowed for nature, like birds, to make their own way to make the best of the house that they can find. So in a way, this shows that what are the importance of say flashing, detailing, and the initial design stage. You have to take into account of nature. Of course, there'll be for broilers, right? Broilers farm. one of the things that we see more common nowadays is that they also include a layer of sealing. So this sealing itself can actually help shield the roof from direct ammonia exposure, right? And when you look at inside, so it seems to be insulated. It seems to be insulating the broiler area. So just like if let's say you live in a landed house, there will be typically no insulation, but the air in between the roof and the ceiling tend to insulate the living area from heating, right? So that is how this actually help with limiting the ammonia exposure to the cladding or the roof. So having said that, the manual that let out from poultry like broilers does not just contain ammonia. It actually contains all sorts of other chemicals, right? It's not as simple as ammonia, right? So here you can see one study shows that the broilers litter, also called manual, actually contains all host of chemicals, and the one that I highlighted, NH4, is actually formed from ammonia, right? And there's another two, which is P2O5 and also K2O, right? So these are components where it is similar to fertilizer, right? So that leads us to the second second topic of fertilizer factory. So in the fertilizer factory, normally you'll see these three components, all right? So of course, you might not recognize it by raw material itself, but rest assured, they are inside this final product, NPK, we call them, right? Nitrogen, phosphorus, and potassium in the component that I mentioned earlier, right? So these three components are crucial to be included as a fertilizer because of their different functions towards the plant, right? Where nitrogen itself will actually green up the plants, right? And phosphorus and potassium has their respective so-called function. So in an industrial setting, fertilizers are produced on a large batch. So it is not necessarily coming from the poultry farm alone, right? It can be produced in a larger setting from industrial chemicals and all that. So typically you can refer them as NPK fertilizer, right? So it will also be labeled as NPK, nitrogen, phosphorus, and potassium. Okay, and of course it can come with different specific formula, as you can see from this slide, where nitrogen, phosphorus, and potassium has different ratio, different numbers underneath it. So, right. So yeah, this is where different fertilizers will actually be used for different so-called different plants. Okay. Sorry, just now I didn't post the polling question, so let me just get back to that. So I think some of you answered. Okay, what are the challenges of the fertilizer plant or factory's design? And I think some of you answered, okay, challenges are ventilation, the roof system design, and also the steel structure, all of them, right? So all of the above. Okay. Anyway, so if you haven't answered, it's fine. I think this is actually to gauge, what is your understanding of the fertilizer factories, right? What are the challenges normally that you face? Okay. So moving on, as I was saying, different fertilizer in different specific formulas in ratio of NPK. It can be used for different plants, okay, and different types of plants require different amounts of NPK. All right. So typically, the one that we have seen in Malaysia is produced to become a powder form or a granular form of fertilizer, right? Basically, bead size fertilizer. So this actually is meant to allow for slow release of the fertilizer. So the fertilizers themselves can release into the soil on a slower basis, so it does not shock the plant, right? So the raw format of this beaded or so-called powdered fertilizer is that it is stored as a powder form, right? And when it's stored as a powder form, they tend to be airborne. Okay, so as you can see from here, this is one of the fertilizer factory that we have inspected, and you can see there's actually chimney spitting out powdered basically smoke lah, right? You don't know what it is, but based on our observation, this powdered or so-called smoke is actually powdered fertilizer, where it was airborne when they were actually mixing it and also making it into beads. So all these powdered or airborne fertilizer tend to settle around any surfaces, all right? And it could actually collect over time, like this photo, where it was actually collecting on top of the machines, right? All kinds of machine. Or on a building itself, it could be collecting on the purlin, right? The steel structure, basically. And over time, because of its hygroscopic nature, as well as readily dissolve in water nature, it tend to form a corrosive effect, right? It will cause the purlin to start rusting, and from there, your roof will start rusting, your fastener will start rusting, right? So one of the factory that we visited also, we saw that the purlin or steel structure actually broke and was dangling around. So this actually posed another safety risk to the factory workers as well. So this photo itself, to put it in context, we actually saw it afar, and then we actually zoom it in to take this photo. So the steel structure was actually on the verge of dropping, and you can see the roof is actually collapsing. So having really proper design actually is very, very crucial in this case, because you do not want this to happen in your factory. So that we'll address later, how to actually prevent that. All right. So another thing that we observed is that, on the roof, there was actually lapping of roof, right? So from here, what we observed is that there was actually two lapping, as you can see from this photo, one on the left and one on the right, right? So the one on the left did not show such severe corrosion, and then actually there was no corrosion on the outside. And then the one on the right actually shows a very severe corrosion, which I'll zoom in to show you the differences. So the one that was showing corrosion, it was somewhat bad, and then you can see actually there was pieces falling off. So this is because there was no sealant applied at the lapping area. Okay, so to share with you the context, when we inspected this roof, the contractor or the owner, the maintenance people, they actually told us that when they replaced a part of the roof, right, from skyline, the contractor did not apply sealant for this lapping. So here you can see that water seep through and to react with the fertilizer underneath the lap area, right? And the one that had sealant actually did not show sign of corrosion on top. But when we observe at the bottom, so this is the one with the sealant applied, and this is the one without sealant. So you can see the one without sealant actually show heavy sign of rust, right? And then the one with sealant actually has also shown sign of white rust, meaning there was actually fertilizer collecting at this lapping area. And the reason why the reaction is not as severe as the one without sealant is because there was no water seep through between the lapping. That is why the reaction is slower. It is helped by the sealant, right? So in a way, this shows you that when there is enough moisture, right, to react with the ammonia, also called fertilizer, it tends to cause the environment to be very corrosive. Okay. So this is a closer look at the lapping area where you can see it is super corrosive, right? So one of the ways that where you can actually address this is, we have seen this done before, is to actually design the building to have a higher roof ground, higher from the ground, right? So this will prevent or so-called minimize the fertilizer dust from flying and settling onto the higher ground, like the purlins and whatnot. And this is another factory lot actually, right? And based on this, the purlins themselves was actually wrapped with a layer of plastic to prevent the purlin from collecting fertilizers in between the C channels and the gaps. But based on our observation, it is not the only solution, not necessarily the only solution, because if we look closer, right, we can see actually the steel structures, the bracing themselves actually has shown sign of a dust collection or fertilizer collection, right, at the steel structure. And when we look at part of the roof, the fertilizers settle on the wrapped purlin. But what happened is that it is in contact with the roofing and it is in contact with the fasteners. So here it started reacting not with the purlin, but with the roof. So what we recommend would be to introduce a layer of underliner. So here compare the one without underliner and the one with underliner, right? Where you can see for underliner, of course, the purlin themselves are actually protected properly, and the roof themselves are shielded away by this underliner. And another example, so it is shielded by either a non-reactive barrier or a reactive barrier. So in this case, it was actually a reactive barrier. It was an aluminum foil. So over time, the aluminum barrier will also still react with the airborne fertilizer. The reason why is because as long as you have metal, regardless of aluminum or steel, it will react in this environment because of the corrosiveness, right? So here you can see, the aluminum foil started rusting and formed some kind of white precipitates or powder. Okay. And another thing is when you choose the type of underliner, you need to make sure that it stays on for the duration that you want it to be, right? For example, 10 years, right? If you want your roof to last for 10 years, make sure that the membrane itself is able to withstand the environment or so-called temperature for 10 years without falling off. So otherwise, you have membrane falling off like this piece right here, and sooner or later the membrane would fall off and then rendered the design useless because there was no more membrane over there, right? So it needs to be rigid and durable. Okay. So aside from that, of course, when the fertilizers is airborne, it could go around the building as well and then go through any openings, right? So this is where the fertilizer could be emitted outside of the building. And this is one of the reasons why the roof would not be just rusting through and from underneath. Of course, that is the primary cause of it. But when you look at the outside, if let's say the fertilizers start accumulating on the what we call unwashed area, meaning areas that are not washed naturally by rain, then the fertilizer would start absorbing moisture from when it's raining, right? Not being flushed away. But the fertilizer will absorb moisture and start rusting or reacting with the roof from above. All right. So this is where you need to pay attention to the unwashed area, right? Any types of unwashed area, whether it next to the jack roof, underneath the jack roof, right? Or at the roof eave, right? So here you can see the purlin, right, is at the roof eave of the jack roof and actually started rusting because there was, fertilizers accumulating at the purlin and also the roof eaves. And also the fertilizer also reacted with the fasteners. So the fasteners that you can see here was actually pulled out, not unfastened out. It was pulled out from the roof. It shows that it has lost its mechanical locking, and it rendered the fasteners useless. So all these needs to be taken into account, right? The fasteners, whether it's in contact or not in contact with the airborne fertilizer, right? So also the unwashed area. And last would be on the dwarf masonry wall. So most often nowadays we can see that some of the warehouse, they actually come with a dwarf masonry wall at the bottom and a wall cladding, steel cladding at the top. So this is one of the designs that we encourage to have for fertilizer factories, especially at the bulk storage area. Because at this area, you can expect the powder, or so-called the fertilizer, to accumulate and to become a small mountain, right? A small hill. And this is where the fertilizer will be in contact with the cladding. So you don't want it to be in contact with metal cladding, because it will start reacting with not just the cladding itself, but also like purlins, fasteners, and it could be disastrous, right? So what we recommend is actually a masonry wall, a dwarf masonry wall, right? So to summarize, today's topic, we covered two. One is poultry farm. So in the poultry farm, we know that the corrosive part comes from the chicken manure, right? Where it can actually let out ammonia gas, right? And because of that, you need to have a sufficient amount of ventilation, right? To actually vent out most of the ammonia gas when it is let out, right? To minimize the concentration within the poultry farm. And also, you need to have a proper manure management system, right? Just now I showed you, there's actually a raised slated floor, and also the manure collection method to minimize the manure from prolonging or so-called staying within the building for too long. And last will be on the suitable roof systems, right? It can be with a proper non-reactive barrier or non-permeable closed cell barrier. And also at the same time, it can also come with a layer of sealing. So all these are actually to prevent or so-called minimize the exposure of the whole the roof cladding from exposure to the ammonia gas. So this in turn prolong the building overall, right? And for the second one, which is the fertilizer factory, we talk about higher roof or ceiling to minimize the airborne fertilizer from settling on the higher ground, and having a more rigid and durable underliner. So this will actually work hand in hand with the purlin that is probably protected by some kind of barrier, to make sure that there's no fertilizer reacting with the steel component. And third would be minimizing the unwashed area, such as underneath the jack roof, or perhaps the purlin at the end, okay, at the roof edge. And last would be introducing a dwarf masonry wall to prevent any types of direct contact with the wall cladding with the fertilizers, right? Feel free to actually access our website for the same information. And of course, we have our platform on Facebook, YouTube, and also LinkedIn. So feel free to access the information via all these channels. You can feel free to email us at events@bluescope.com.my. And as always, thank you. So just a reminder for architects who would like to submit your LAM CPD points or get your LAM CPD points. Once this event has ended, you can actually exit from the platform, and there'll be a pop-up screen, presented on your screen, and you should be able to fill the survey form and along with your LAM membership number, and there we will actually submit that to LAM. So with that, thank you, and see you in the next session.